Hi, my name's Ben Smith. I'm the business line manager for industrial gas for Pneumatech. Today we're in Nebraska. We're taking a look at one of our nitrogen systems that's been installed at a food processing facility here.
So we process different types of products here at this facility, mainly proteins. We inject nitrogen into the packages of the product.
It removes the oxygen from the atmosphere inside that packaging and allows for a low oxygen environment that prevents spoilage over time. Most facilities looked at nitrogen as a utility. An outside vendor brings in nitrogen either in bottles or in bulk liquid. There's a lot of problems with doing it that way.
So you have a humongous cost in piping that liquid nitrogen throughout the plant. And if you bring in the bottles of nitrogen, the cost is higher there, but you also have to have people that can handle those big bottles.
So if you're buying your own nitrogen, you're going to be paying about 80 cents per 100 cubic foot. Now, if you're buying bottles, that's even going to be even higher. So then you're looking at about $2.50 per 100 cubic foot, as opposed to 8 to 28 cents per 100 cubic foot with an on-site system. Pneumatech's been around since 1966. It was founded in Kenosha, Wisconsin. We've been doing nitrogen systems since the early 90s.
The support that these guys gave us was great.
At Pneumatech, we offer two different types of nitrogen systems. We offer a membrane system and a PSA system. At this particular customer, we decided to go with the PSA system because of the purity and the flow that they required. Quality is essential in the food industry. It has to be there. It's probably the most important thing.
And so this is the safest means of bringing nitrogen into a facility.
So this is the PPNG 90. So we come in on the air inlet. At this point, what we do is we monitor the temperature coming in. We're going to monitor the pressure coming in. And something that we do that other manufacturers do not do is we're actually monitoring the dew point. Basically, we're going to pick up any type of water that may be coming into the inlet of this generator. It'll close the inlet valves off and prevent the generator from taking on any moisture into the towers with the carbon molecular sieve. These are extruded aluminum vessels. The compressed air is forced up through these chambers, and inside the carbon molecular sieve, under pressure, removes the oxygen molecules from the compressed air supply and strips them and sends them to atmosphere. And then what we have is called a customer valve down here at the bottom. And that customer valve does a couple of things. One, it opens when the purity is at the right point. Now, this is important because if the purity is not up to the point that it needs to be, we don't send any of that nitrogen downstream. That means that the customer's process does not get contaminated with oxygen when it should not be. And also allows for that automated startup. As standard, we add a flow meter in line on the outlet of the generator. The controller monitors the flow rate, compares that with what the maximum output of the generator is, and then adjusts the cycle time of the generator in order to save compressed air. And this can have up to 70% energy savings using that variable flow saver technology.
We have control of this system. We don't have to rely on an outside source of bringing in liquid nitrogen or worrying about when the delivery was going to be made. You know, uptime for us is tremendous. If we're not up, we're not making the money.
We normally see at most facilities a 2 to 3 year return on investment. A lot of times even quicker.
And I believe that in the future, all companies will go to using compressed air nitrogen system. No regrets at all of putting the system in. The system is a great system.
As far as efficiency and what we're offering the customer, nobody can compare with what we're doing.